This video is going to talk about the distributive property. The distributive property basically means that you have a number multiplied by a sum. So for example, you have 3 multiplied by 4 times 5. Now, if you were to follow PEMDAS, what you would do is you would do what's in the parentheses first. 4 plus 5 is 9. 3, you carry down the 3. 3 times 9 is 27. But there's another way that you can approach this particular type of problem. Instead of doing what's inside the parentheses first, you would take the number on the outside and multiply it by everything that's on the inside. So you'd take the 3 and you'd multiply it by the 4. You'd have 3 times 4, take the 3, multiply it by the 5, 3 times 5, and you still keep that addition, so you put the addition sign right there. So now you have 3 times 4, which is 12, plus 3 times 5, which is 15. 12 plus 15 is still 27. So you get the same answer both ways. We're going to look at some situations where you're not able to have the choice between the two, which is why the distributive property is so important. The first thing we're going to look at is how this can help you when you are multiplying a number times a mixed number. So instead of looking at this as 4 times 10.5, you can think of it like 4 times 10 plus 1/2. And 10 plus 1/2 is 10.5, so we haven't changed anything. Now we know that 4 times 10, it's pretty simple, that's going to be 40. And we can also do 4 times 1/2. Put that addition sign in there because it was up here. And 4 times 1/2 is 2. So instead of having to think about what's 4 times 10.5 and doing the backwards C, 2 times 10 plus, instead of doing all that, we can just do this and get our answer of 42. That's something that you can use to think about multiplying by mixed numbers in a different way. However, it's not the most important thing to use the distributive property with. The main part of the distributive property is over here, and that's where you have a number multiplied by a variable plus another number. And when we use the distributive property here, we're not going to get one nice clean number. You're going to have to stop at a certain point, and it will look unfinished, but it will be as far as you can go. So let's take a look. We're going to take this 5, multiply it into the x. What is 5 times x? Well, I don't know what x is, so I just have to leave it as 5x. And that's all I can do with it. I can't go any further. I can, however, take 5 times 6, and I know that 5 times 6 is 30, but again, I don't know what 5x is. So I'm just going to leave that as 5x. And this right here is my final answer. This is something that you're going to be seeing a lot in the future. And it's very important to remember that when you distribute, you multiply the number into everything inside the parentheses. There's also a way of looking at this backwards. Let's see if I can not hit the cord here. And this is called factoring the expression. And when you factor the expression, purple, green, orange, you're going to basically do the opposite. These have already used the distributive property, and we're going to work backwards on it. So when we look at 12 plus 8, I want to see what number can multiply into two numbers being added to get 12 plus 8. So I take the 12, and I take the 8. And I need the factors for each of these. And we could do a factor tree for 12 and a factor tree for 8. But in the end, it's going to end up being 2 times 2 times 3, and 2 times 2 times 2. I'm not going to put you through the factor trees. So now we look at the numbers that we have in common. And we get a 2 here and a 2 here. Join these up together and you get 4. So now I know that 4 multiplies into both of these, so I'm going to write it on the outside. What number is left? You have a 3 left in the 12 and a 2 left in the 8. So what this means is if I take 4 times the quantity of 3 plus 2, and if I multiply these together, 4 times 3 is 12, 4 times 2 is 8, I get the same thing as before. It's like reverse engineering this. So let's take 18 plus 9. For 18 plus 9, I'm going to take the number 18 and the number 9. I'm going to remind you how to do the factor trees for these. We have 18 broken down into 9 times 2, 9 broken down into 3 times 3. So for 18, the factors are 2 times 3 times 3. And for 9, well, that's already in my factor tree. The factors are 3 times 3. So the factors match up that are 3 and 3. And 3 times 3 is 9. So 9 will be on the outside. It can multiply into both of these. For 18, there's a 2 left over. So I'm going to put a 2 here. For 9, there is nothing left over. And when there's nothing left over, the only thing left is 1. So this boils down to 9 times the quantity of 2 times 1. Now, this doesn't really seem to make a lot of sense. Why would you go ahead and work this backwards? It seems to be a waste of time. Until you get to something like this, where you have a variable in here that you don't know what the answer to this is. And then we want to reverse engineer this, and this is where it starts to get important. So I'm going to take the factors for 3x and the factors for 15. So when I break down 15, I'm going to get 3 times 5. But when I break down 3x, I'm still going to get 2 numbers. I'm going to get 3 times x. And I don't know what x is. So the only numbers that 3x and 15 have in common is the 3. So I'm going to put this 3 down here. So I know that 3 goes on the outside. And on the inside, you're going to have x and 5. So 3x plus 15 is the same as 3 times x plus 5. This is going to be one that we're going to talk about more in class. I know that it takes a little bit more work to kind of finagle and make sure that we're comfortable with. But for your homework, I would like for you to please to try using the distributive property on 2 times x plus 3 and factoring the expression 12 plus 9.